Hello everyone, in this video we are going to configure the Atmel Studio 7 to program the Arduino UNO board. Normally we would use the Arduino IDE to program the Arduino UNO board. Okay, simply write your sketch, okay, and then click program to program. Okay, say for example, if I change this delay to 1000, okay, I click on upload. The Arduino IDE will automatically compile the program and then upload it to the Arduino UNO board. We can do similar things. Okay, you can edit Arduino Sketch inside Atmel Studio 7 and then use Atmel Studio 7 to program the Arduino UNO board. First, go to New Project, okay, and then create a project from Sketch and then name your project. And then you have to find your sketch file. Okay, normally you would point to any sketch file that you have. Okay, ended with .ino. And then the Atmel Studio will automatically find the Arduino IDE installed inside your PC. Okay, to do this, you would need to install your Arduino software and then choose the board that you're interested in. Okay, and in our case, we are going to program the Arduino UNO and then click OK. The project will load the Arduino sketch. In my case, the sketch is the Bling sketch. Okay, and you have all the codes generated inside your Atmel Studio 7. The nice thing about using Atmel Studio to write your Arduino sketch is that it allows you to simulate what is happening inside your microcontroller. In this case, the ATmega 328P microcontroller. Okay, just choose a simulator, okay, as your tools. Okay, and then click on use the debug functions of the Atmel Studio to see what is happening inside your ATmega 328P. Okay, let me hide the Arduino. Start the simulation, okay, by clicking on the step into. Okay, what I can see is the full code, okay, of the Bling Arduino Bling. Whenever you run your Arduino program, okay, what actually happens is that you start with the main codes. Okay, the C will always start with the main code. Okay, and then from the main, okay, you will do some initialization first. Okay, and then do the setup, and only then goes to the infinite loop where you call the loop function of the Arduino UNO. We can then go through, okay, the executions of the code, okay, one by one. Say after calling for init, okay, you can go inside the init functions. You can see that Arduino starts by setting the global interrupt to high, okay, and then setting up the timers. This is a timer register of the Arduino, and etc. Okay, and then Arduino will do the init variant. Okay, this is to initialize according to the Arduino board type, and then go to the setup, where inside the setup, okay, finally jump to our own code, which is the Bling code, okay, where we'll do the pin mode. Okay, the pin mode itself is a function call, where when you call for the pin mode functions, you will actually go into a much longer codes, okay, which is inside the wiringdigital.c file. And then after that, only we will go to the loop, okay, and executes the loop. And if we go into the loop, Okay, you can see that uh, we are going to do several function calls: digital write, delay, and digital write. And in digital write, when we step into digital write, you can see that again we go into wiring digital.c. Okay, and then delay, step into delay, we'll go into wiring.c, okay, to do the delay functions. Okay, so yeah, then we can execute and see how delay is actually executed, okay, line by line. And interestingly, also you can view the equivalent assembly of the Arduino code. Okay, well, actually, this is the program, okay, inside the flash memory. This is the flash memory of the 80 mega 3.p, and basically these are all the instructions that is uploaded into the Arduino microcontroller, sorry. Okay, and you can actually see what does this instruction in details by using the disassembly, okay, using the disassembly window, debug window, disassembly. Okay, and inside this disassembly, you can see the whole codes, okay, where this first jump, which is 0C945C00, okay, which is that 0C945C00, okay, is the first instruction that will be executed by the Arduino when it is turned on. Okay, and now let's see how you can program the Arduino using the Atmel Studio. Okay, to do that, we stop the simulation or stop the debugging, and what we have to do is we have to uh, set an external tool. Okay, for in my case, I have already set my external tool, but for this exercise, I will do that again. Okay. Okay, so what you have to do is you add a new tools. Okay, in my case, the Arduino Uno. Okay, the tools is called Arduino Uno. Okay, but you can name your Arduino Uno programmer whatever name that you want. And then uh, this is important. Okay, for Arduino IDE. Okay, when you run an Arduino IDE. Okay, when you click on upload, what the Arduino IDE will do is that it will use a tool called the avrdude.exe that will upload the hex file that is generated by the compiler of the Arduino IDE into uh, the Arduino Uno board or the microcontroller of the Arduino Uno. Okay, and if you press and upload, okay, you will not be able to see that much details. But if you enable the verbose functions, okay, the verbose output, when you compile and upload, okay, you will see a lot of details here. Okay, and let's try to upload again. And you can see that, okay, the orange color text is when the Arduino is downloading. Okay, and you can see the final message is avrdude done. Thank you. Okay, and right before the upload text, okay, you can see this. It's very long command. Okay, where you see that the Arduino IDE is calling for a tool called avrdude. Okay, and then along with that, it gives some parameters or gives the arguments for the avrdude. So what we do here now is to copy this. We can actually copy this, okay, or you can find your where the avrdude in your computer is located. Okay, in my case, it is inside the program file Arduino hardware tools avr bin. There, avrdude, and then uh, for the arguments, okay, what you can do if you want to understand the arguments, you can try to run avrdude from the command prompt, okay, and see what are all these arguments about. Okay, in the in the case of our Arduino IDE, okay, use the -c, okay, to specify the config file, and then -v -p to specify the board, and then -c for the programmer, -p for the COM port, -b for the baud rate, -d, and then -u to specify the flash file. Okay, and you can see all these parameters. What are they for? Using the help functions of the avrdude. Okay, and let's set up our Atmel Studio. Give a name. Okay, and then for your programmer, okay, you have to specify avrdude.exe. Okay, what you can do is you can copy this, okay, and then add in the .exe then. Okay, and then for the parameters, the arguments, can copy the whole thing. Okay, except for the last part. Okay, you don't want to use the same hex file, because here this hex file is the hex file generated by the Arduino IDE, which is inside your username, app data, local, temp, and then the Arduino build numbers, and the ino.hex. Okay, in our case, okay, our hex file that is generated by the Atmel Studio will be in your project directory. Okay, it'll be in your project directory, and then debug, and then the target name dot hex. Okay, target name is the name of your project. Okay, and you can actually see, okay, in your project file. Okay, here is my project file. You have the debug, and then you have the hex file generated. Okay, this is generated when we do the simulation before. In order to simulate, Atmel Studio have to generate or have to compile to run the compiler that will produce all this file. Okay, so just add in project directory debug / the target name.hex at the end. Okay, and then okay, and now we can program our Arduino UNO board there. Okay, and let's change the blink frequency. Okay, make it faster. And once you change that, you have to rebuild the solution to generate new hex file, and then to upload, click on tools, and then click on the external tool name that you have created. Okay, and you can see the Arduino is blinking faster. Thank you.